Hi, you're viewing the Sparky Automotive Investment Pitch. Thank you for your kind attention. We explain the poor state of the electric vehicle market and problems caused by designs based on combustion engine cars badly adapted to electric drivetrain. We explain that with a few reasonable design compromises, a car can be produced very much more simply than by traditional combustion powertrain methods. We show this leads to a major opportunity for simple, cost-effective EVs and demonstrate our progress in production and marketing of a prototype and partial units. We show we have extensive experience in microcar construction and certification. We show there is a potential market in the UK around the 200,000 units figure. We give cash flow forecasts showing how, with modest investment, we can address this opportunity and produce substantial profit over a 2-year period. We discuss likely future growth and development for cars based on our simple design model. Sparky business model of affordable EVs. The current electric vehicle market is failing. The electric vehicle market, both sides of the Atlantic, is failing. Much to the delight of petrol heads and others with vested interests in cars powered by internal combustion engines, the electric market has run into a number of blockages and constraints which are restraining the uptake of electric vehicles and threatening to thwart EU and US government plans for replacement of petrol and diesel over the coming decade. Among these problems are continued issues of range anxiety for more affordable vehicles, the continued high cost of new cars, the non-availability and high cost of reliable charging points, and the time taken for recharge of bigger vehicles. There is also the weight of many cars which are nearly 2 tons, and stories of huge repair costs and worse depreciation figures. The result of all this has been a hiatus in sales of many EVs, issues with the profitability of EV lines of product from some manufacturers, reports of a glut of unsold Chinese cars and, overstated, reports of fires resulting from bad management of lithium-ion batteries. Distinguishing these market factors from the propaganda promoted by oil companies is difficult, but there is nevertheless clear evidence the EV market has serious problems. A notable exception to this trend is Tesla, which shows continued sales success, but even its profit margins are falling, and its much vaunted affordable Zoo car has yet to appear. It remains a premium brand with comparatively small, 2 million, volumes. Toyota and Ford sell around 15 million units between them. Remedies. The above problems all stem essentially from the same source. Car manufacturers have simply tried to replicate the traditional 2-4-door saloon model of a standard car manufacturer, substituting electric technology for the traditional combustion power train. Examples are Volkswagen and Ford, who offer several models with a choice of power source, albeit the electric versions are much more expensive. At the heart of the problem is the 3-way trade-off to which electrics are subject. Either performance, price or range must be sacrificed to produce a competitive car. This is why Tesla have good performance and range at a premium price. The car is lighter than many other electrics because battery weight has been mitigated by making the car from lightweight aluminium, but at a price. We believe the most effective way to produce affordable electrics is to make a limited number of sensible design compromises which address the above trade-off problem, whilst broadly maintaining the functionality of the car. Compromise 1. Weight. We can address the weight problem simply by making the car smaller. Research shows that around 85% of car journeys only carry 1 or 2 people, so we make a 2-seater. This results in a car weighing less than half a ton, far less than most current electrics. Compromise 2. Range. Again, research shows that the overwhelming majority of car journeys are less than 50 miles. Typically a UK commuting distance is around 20 miles in each direction. A battery capacity of 60 miles, 100 kilometers again covers most needs in real usage and can be improved with a range extender. Compromise 3. Performance. Combustion car speeds will typically top out at around 100 miles per hour, 160 kilometers per hour. This far exceeds what is lawful virtually everywhere, and in many cities road speed is limited to 20 miles per hour, 32 kilometers per hour, requiring far less power and energy storage capacity than most electrics currently on the market. Our business model. Accordingly, we have started again at designing an electric car from the ground up, taking account of the above compromises in getting to an affordable vehicle which still offers practical urban transport. 1. Weight. We start from the advantageous position of a successful original design, specifically the Isetta bubble car. Essentially a glorified motorbike, this car enjoyed considerable success after World War II due to its affordability and low fuel consumption. It features a reverse trike wheel layout which has road-holding advantages. Its front opening door also adds to its iconic status, with original cars now fetching tens of thousands. 2. Range. The smaller quantity of material in the unit enables much better energy economy than the typical electric, which gets around 5 miles, 8 kilometers, per kilowatt-hour. We offer a far more efficient 12 miles, 20 kilometers per unit of electricity. 3. Cost. The above efficiency resulting from a weight of around 400 kg, a quarter of many electrics, it means we need much smaller energy storage capacity than other cars. Typically 6 electrical units will take us 100 kilometers. This means we need spend a fraction of other EV manufacturers' costs on batteries and can reflect this in the selling price. It also makes for much quicker recharge times and enables full recharge from a 3-pin socket in under 2 hours, or much quicker from a recharge point. Like all electrics, we have very low maintenance. Accordingly, we believe the answer to the EV market problems comes by rearranging the EV business model along the lines outlined above. We are far from alone in this, with a variety of manufacturers worldwide making strenuous efforts to address the adapted business model in the ways we have suggested. Names like Aptera, Renault Twizy, and Microlino spring immediately to mind, and we wish their vendors all the luck in the world. Our machine's construction. The key to getting a device on the road is simplicity. As Elon Musk said, the best part is no part at all. It costs nothing, needs no servicing, and never goes wrong. We have adopted this principle in spades. Our machine has no gearbox, no carb, no clutch, no radiator, no transmission, no differential, no fuel pump, and no exhaust. The powertrain has one moving part, the hub motor, which together with the battery comprise the entire drive system. There is very little to go wrong and hence no maintenance. There is no transmission to absorb energy. The above powertrain is complemented with an off-the-shelf front axle, like the rear motorbike swing arm. This is made by Suzuki. To the resulting rolling chassis, we add a GRP body shell, again available off-the-shelf thanks to the constructor-restorer community, braking system, lights, instruments, interior, and seating, and the result looks something like the video footage. As a replica of the iconic Isetta bubble car, the machine has immediate recognition and enthusiastic adoption by the public. Also, being derived from a classic car, we benefit from the continuing Isetta constructor and restorer community, who have thus far provided our initial revenues together with enthusiastic support, for which we are most grateful. We have made a point of recording our activities with image and video to illustrate progress towards production car capability. Accordingly, we can show the various stages of car construction, illustrating its simplicity and affordability, whilst the result is a fully roadworthy machine. Traction and market analysis. Our journey thus far has been characterized by a high degree of support and enthusiasm from the constructor community and other interested parties. We achieved seed funding from the British Business Bank with very little formality, and similarly we have achieved a degree of press coverage far beyond what our level of activity would suggest. We have successfully constructed a rolling chassis using the above parts and have complemented this with a prototype body shell as shown in the videos. The availability of the prototype has complemented our presence at exhibitions and enabled the compilation of an image and video portfolio to facilitate communication with interested parties. We now have an enthusiastic and growing team of keen professionals. Brunel University have been very supportive through their Co-Innovate program, and we have also benefited from mentoring by startup consultants. We have registered Sparky Auto as a limited company and can develop our trading activities at short notice. There are a number of ways to estimate the target market for affordable EVs. Considering the worldwide petrol and EV figures for 2025, we get 90 million and 9 million respectively. We also consider the numbers for e-bikes and e-scooters as relevant and get numbers of more than 100 million. Rough estimates narrow the UK market to 2 million vehicles. Guesstimating on the basis of these figures leads us to a credible number of 200,000 affordable EVs designed using e-bike scooter technology, but we believe this to err on the conservative side. A mere 1% of this figure is 2,000 machines, which would be an ambitious but far from hopeless number to aim at in the medium term. We propose to advertise and promote our cars at every opportunity. Its iconic look and original layout attract attention wherever it is seen, and we propose to take full advantage of this with showroom and test drive facilities. We have trailed the units through eBay and Etsy, and the response has been inquiries in the thousands, so we are convinced of high sales volumes if we can make good machines affordably. Whilst we have thus far obtained much initial success and encouragement through the means and methods mentioned above, we have now reached the limit to which our personal means can support the project. Accordingly, we are pitching for a degree of external investment to develop the opportunity we believe the EV market now offers, which is the purpose of this video. Our plans: see cash flow forecast numbers. We want to make cars. We believe the electric car market is reaching a stage where our type of lower cost and easily recharged solution is coming into its own, and is a far better proposition than the mainstream manufacturers' attempts thus far. Accordingly, we have projected UK manufacture over the next 2 years to take us to a volume of 30 units, 23 in year 2. After this, the sky is the limit. See the illustration for our starting figures, but remember, no battle plan ever survives first contact with the enemy. We project that in the first year, we will sell 7 cars in our production pilot. This is not many, but it will establish our credibility as a manufacturer of reliable cars, which pass certification and are roadworthy as a result. We will also likely benefit from PR and publicity as the new kid on the block. We will also be established with suppliers and government agencies as a firm who pays its debts and submits its paperwork on time, all good foundation for going forward. We have budgeted a significant spend on advertising and PR so there is public awareness of our product in the UK market. Year 2 is when we actually start motoring. We have projected making and selling 23 cars, taking our total to 30. We expect to accomplish this by outsourcing manufacture, and a couple of well-known British firms have expressed interest. Economies of scale start to kick in, so the unit cost is going down whilst the selling price we can maintain at a competitive £10,000. Accordingly, our top-line margin gets better and the cash burn rate at the bottom line is levelling off as we approach break-even. In year 3, we propose to again triple our output to 70 units. Detailed numbers for this are not realistic looking this far out, but this should produce a profitable turnover around £700,000. Applying the 6 times rule, this gives a valuation of £4,200,000. This represents an ROI around 800% on the basis of the original £500,000 invested. So much for the theory. Whilst we believe the numbers quoted are realistic when quoted on paper, their realization is contingent on a high level of physical activity on the part of the directors and friendly subcontractors. Accordingly, we have budgeted substantial numbers for fixed costs. These will cover modest initial directors' drawings, plus NI, and reasonable expenses. There is a figure for a demo test drive facility, plus a budget for advertising and marketing or PR. Moreover, there will be admin in the form of government submissions and possibly VAT, and we have included figures for insurance and warranty costs. Who we are: Director's background. Founder Principal Director Martin Langley. Martin has an Honours BSc degree from well-known technology centre Brunel University. He is a certificated electrical engineer. The idea of an electric Isetta replica was initially proposed by Professor Heinz Wolff, who built an electric prototype by converting a petrol car. Following a successful career in IT, Martin founded Open System Services Limited, which employed up to 10 people and traded profitably for several years. He lives in the Richmond area of West London and is a regular visitor to constructors' clubs and repair parties. Martin has substantial startup experience and is aware of the issues faced by new firms. He is also very practical by disposition and has successfully repaired audio equipment and engine cylinder heads in addition to IT server building and deployment. Technical Director Mike Robbins. Mike is a highly qualified chemist, BSc CSc IC Chemistry FRSC, with extensive experience in fabrication using GRP materials, and design of micro-car replicas including Isetta and Bambi. Mike lives in Clecton-on-Sea, where he has a well-equipped fabrication laboratory adjacent to the glorious sandy beaches of Essex. He has extensive experience in fabrication of micro-car replicas, including knowledge of roadworthiness certification. See images for a selection of Mike's replicas and body shell work in progress. Other inputs, we use subcontractors for chassis construction and battery fabrication together with marketing professionals to provide advice on product advertising and attendance at shows, etc. We started our construction activities in constructors' clubs with whom we maintain friendly relations and use their equipment from time to time in return for providing revenues by reselling their surplus kit. Possible futures. We have the utmost confidence in our reverse trike business model, and we are also keen to explore possibilities of alternative styling using a variety of body shells. In particular, the replica Toyota machine has garnered considerable interest, and we would also look at an Aptera replica in the likely event they cannot get their sexy machine into any kind of volume production. We have even had inquiries asking for amphibious machines, but our technical expertise does not yet run to aquatic design. We are also keen to explore the export possibilities of the car layout. We can bring the unit cost right down by supplying the car in kit form for assembly in countries where local manufacture may be more cost-effective. India looks like a likely candidate here, with a burgeoning electric tuk-tuk market for vehicles designed for local delivery. We have a number of potential partners who have expressed interest in the units if we can get the cost down. All the indications are that the internal combustion car model is nearing the end of its useful life. Peak oil liftings are projected to occur in the 2020s, and regulations to reduce global warming are becoming stricter and more widespread. At the same time, the combustion business model is becoming increasingly uneconomic as the powertrain is heavy, complex, wasteful and expensive, requiring regular labor-intensive servicing. By contrast, the electric powertrain is simple, reliable and cost-effective if sensibly used. That said, to date the use of the electric powertrain has been far from sensible, and has resulted in the myriad problems referred to earlier. All the more reason for us to have confidence in the revised business model at the heart of our proposition. We take the simplicity of the e-scooter powertrain and use it to enable a roadworthy car. If we can get these cost-effective EVs in front of customers credibly, there is every reason to believe they will eventually be as ubiquitous as mobile phones.